Welcome. In this tutorial, we'll write a C# program that finds and sums the first 500 prime numbers. This task exercises loops, primality testing, and accumulation patterns. We'll also explain a straightforward primality check using trial division up to root n. Iterate until we've collected 500 primes and keep a running total. And finally, we print this up. This is practical for learning algorithmic thinking, especially efficiency trade-offs when searching for primes. Let's walk through the plan and code. We're not reading user input here. The program generates primes beginning from 2 and keeps going until it has found 500 of them. For each candidate number, we test primality, which is simple but effective for the size. We then add the prime to our running sum, increment our count, and continue. When the count hits 500, we then print the sum. The expected result shown in the sample output is 824,693. Here's the full program. Main keeps the sum, CTR, which is count of primes found, and n, which is the current candidate. The loop runs until CTR is equal to 500. For each n, the helper is prime test primality by checking divisibility from 2 up to floor root n. If is prime n returns true, we add n to the sum and increment CTR. This straightforward approach is fast enough for 500 primes and very clear for learners. The algorithm is iterative. Try each integer, test primality, accumulate when prime, and stop after 500 primes. The primality test uses trial division to root n. That's big O root n per candidate. For the scale, which is the first 500 primes, that's perfectly fine and keeps the code readable. If you needed many more primes, you might switch to the sieve-based methods for speed. This table illustrates the running accumulation as we find primes. The first few primes are trivial. As n grows, primes become sparser, but the loop still finds them reliably. After the 500th prime is found and added, the program prints the final sum. If you'd like to see intermediate progress, you can log each prime inside the if is prime n block. While the direct sum of the first 500 primes is mainly an educational exercise, the building blocks are widely relevant. Efficient primality testing and prime generation are central to cryptography and number theory tasks. This tutorial gives a clear, testable baseline implementation that you can optimize for later. For example, by implementing a sieve of Eratosthenes or caching earlier primes for trial division. In summary, this solution is simple, reliable, and great for learning. For performance at much larger scales, consider sieve methods or testing divisibility only by known primes. So it speeds up the trial division. Also, consider using long if you plan to sum a much larger quantity of primes to avoid overflow. Try modifying the code to print progress or to collect all primes into a list for later use. Thank you for watching. If you enjoyed this video, please make sure to like, share and subscribe for more C# tutorials. I'll see you in the next one.